Good morning, Year 11 Science students. Today we're going to go on to finding out the distance travelled for objects using a speed-time graph. So this here is section A. The object has started at 0 and it's ended up doing 15. We'll put it a unit, ms minus 1 meters per second. So what we've got to try and do is find out the area under the line which is equal to the distance travelled, and that's the way it's done in all of the SciPad questions. So to do that, we've actually, having a look here, I've done an orange triangle. I've made it into a triangle. You should know that the formula for the area of a triangle shape is half base times height. So if we got our base here is 0 to 20, so we'll just do this as section A here, 0 to 20, half of that, so it's half of 20 times the height, which is 15. So effectively it is 10 times 15, and section A gives us 150 meters. Let's move on to section B. So section B is a rectangle, so therefore we don't have to use the triangle formula. We can just find out the area of a rectangle, which is just base times height. So this one here is the difference between 40 and 20, which is 20. So it's 20 times 15, which gives you 300 meters. Another 300 meters is travelled during that period of time here. At this point, it starts to decelerate, and it decelerates all the way to 0. So again, we've got a triangle. So for section C, we've got a triangle shape, and we've got to use our half base times height formula. So the base is going to be from 40 up to 50, because there's 60, so it's 40 up to 50. So the base is going to be 10. So it's half of 10 times 15, which gives us 75 meters. Another 75 meters covered. This next section here, section D, is actually 0. Because it's got 0 height, even though it's been doing 0 from 50 seconds to 80 seconds, so it spent 30 seconds going 0, it becomes 30 times 0, because the height is 0, so therefore it is 0 meters. I'll just write it in. So half of 30 times 0 is the working for that one. And then we go up onto this one here, section E. And for this one, we have got half, again, it's 30 times all the way up to 55. And that gives us 825 meters. And our last section, section F, it's this big rectangle, so we don't have to do the half. We can just go 55, which times by 30. So the base is 30 from 110 up to 140, and we times it by 55, and that gives us 1650. If we wanted to find out the total distance that this object travelled during this journey, you just add all of these numbers here up, and you would have your total just down here. Okay, I'm just going to point out that, there's the total there at 3,000 meters or 3 kilometers. The logic behind this links back to our formula, which is velocity is distance divided by time. And we are trying to find distance, so it becomes distance is equal to velocity times time. So you can see for the rectangles here, our velocity was 15, so velocity, and our time was 20. So it works just velocity times time gave us 300. For the first one where it's a triangle, we had to do half because it started off at 0 and ended up at 15. The actual velocity for this section here is halfway between 15 and 0, which is 7.5. So it will work out if we go 7.5 times 20, because the average speed here would have been 7.5. First half it's doing less than 7.5. Second half it's doing more than 7.5. So 7.5 times 20 will give us the 150 meters as the same answer. So you can think about it using the physics formula Or you can use this rule that the area under the line equals the distance travelled.